Hello, everyone. It's Tuesday. It's time for Startup School, Gen AI. We're welcome. Good morning, good afternoon, because we have people joining from different places around the world. This is Timon, your host, your MC of Startup School, Gen AI. And let's build something, okay? Let's build a chat app. Let's build a fantastic AI agent, and today we're going to lay out the code pipelines for our GenAI customer service apps. We have a fantastic speakers today, and we're going technical today. So get ready for this. But just before we jump into the lecture itself, it's of course my duty every time to just quickly remind why we are here and what are the rules. So we are in week 2. We are starting after understanding what happened with the GenAI world and the Google GenAI world. Last week, we were talking and going deep into the whole ecosystem. I hope you liked it. We saw your feedback. So if you haven't shared your feedback yet, check the email. And there was a Google form there to let us know how you did in the first week. But we have a week now, week 2 right now. We're going to build out the code pipelines and define user journeys. Next week, we're going to have fantastic lectures with our partners, MongoDB and NVIDIA. And then in week 4, we're going to finish it all with orchestration and deployment of our customer service app. Just a quick reminder for all of those you who've been listening last week, you know the drill already, but for those of you that are quite new here, we have a live sessions every Tuesday and Thursday, and we have a skills boost labs and notebooks that we recommend you to do in your free time, so that you can practice what you have learned. One important information for you, and now please focus, the link that you can see in the point number 2, this is Google/GenAI-labs. Please remember that this link is, it's important to put the capital letters when they are. So G, A, I, and L are capital, otherwise you won't get it. And just please revisit this link from time to time. And sometimes you need to clear the cache of your browser so that you are sure that the PDF that you are viewing is the most fresh one. We have updated it with a couple of new notebooks and labs that are recommended. So make sure you're not viewing the one that you just viewed, a week or 2 ago. When it comes to the skills boost, I saw that many of you, like literally thousands of you, already obtained the credits for Skills Boost platform so that you can finish the labs for free. Here are the instructions. Here's the QR code. If you need still this first URL to get the credits. If you still have any problems, please reach out to us at startupschool-external@google.com or support@quicklabs.com. Many of you reached out and we have solved all of your problems. So that's a good sign. And I'm happy to see that you are really enjoying the skills boost, that you're finishing the labs, that you're obtaining the badges for the labs. So that's great to see. But without further ado, just a couple of housekeeping rules. A quick reminder, you have a chat on your right-hand side. I'm going to pop in the chat just in a second. Please, our idea for the chat is for you to get to know each other and also comment live what you're seeing. Please try to avoid the LinkedIn flood. We saw that in the first week, but like just to keep it nice and tidy and as actually place for chat, please try to avoid the LinkedIn profiles over there. But the more importantly, there is a Q&A panel below the screen. If you have a question that is about our code pipelines, about Gen AI, about customer service apps, you want to learn from Google's AI experts that are right here with us, please pop your question there to the Q&A panel. We'll try to answer all of them. You can also upvote the questions that seem to be interesting to you. And at the end of this class, we're going to have a Q&A and ask a few of those questions, the most popular ones, to our facilitators. We're not sharing the slides, but as you already know, we are recording this one, so you're able to rewatch it on demand on the very same platform. Just one caveat, this session we'll be able to rewatch in about 8-10 hours when we finish our second session in more America-friendly time. So we will have to wait a little bit. But tomorrow, wherever you are tomorrow, this one is available on demand. Last but not least, labs or notebooks that we're going to mention today. You don't need to do them while the instructor is doing them. You know that they are guided, so you have plenty of time with your credits to finish them in your free time, but don't forget about them. The best, I think, is to revisit it, later today or tomorrow before the next class to make sure you're familiar with the topics and that you can confirm you got the right skills. And with that, I just wanted to introduce our two speakers, two fantastic experts that we have invited for today's class. That's Naveen and Charu. If yes, you are here. Thank you very much for finding the time. I'm pumped a little bit, and I really hope that we're gonna see the first stages of building this customer service apps, how we're going to build the code pipelines. We're going to see each other in about 60 minutes, I guess, for the Q&A. But until that time, the floor is yours. I will let you introduce yourself. I'm just going to disappear in a second, but good luck to you. And remember, energy.
Thank you very much, Simon. I think you said the energy levels right. Hello, everyone. We are really excited to be speaking and giving this session to you today. So today, I'm Naveen Pusarla. I'm an AI consultant, part of Google Cloud. In my day-to-day job, I work with enterprise customers and building AI-based applications from a business point of view, right? And so we build end-to-end application to solve a business problem for an enterprise customer. So as part of my job, I often get an opportunity to solve some first time in the world kind of applications, and especially with Gen AI, I think the possibilities are enormous on the way we are solving the problems. And again, really excited to talk to you this session. Charu, over to you.
Thanks, Naveen. Hi, everyone. I am Charu. I work with cloud team, as Naveen mentioned. I am actually AI engineer. I work on I use code to build AI ML applications, help customers solve their problems. And currently, as you are learning, I am using Gen AI to solve the problems. Thank you.
Thank you very much, Charu. Now, let's see what we are going to cover today. So we are going to take a couple of use cases and drive this technical session from a use case point of view. So, for example, you have a problem to solve and you wanted to solve it using Gen AI. So, how do you go about it? Like, how do you experiment with it, and what design considerations you would have while finishing your experimenting and starting your design and build cycle, and what you need to consider while actually designing end-to-end application and building it. And also we'll quickly look at how we can deploy an end-to-end application with a demo in GCP. So remember, all this you could do in GCP as a platform, because that GCP gives you that end-to-end platform, along with the models, infrastructure, and tools for you to build a production-ready, scalable, and high-available application. Towards the end of the session, we will have time for Q&A. Please post your questions in the chat, as Thamin mentioned. So with that, let me move on. So I'm looking at a couple of use cases here. Of course, we have number of use cases for Gen AI, but I picked up a couple, and we are going to use these use cases as direction throughout the session, right? So first one is we want to build an app, a Gen AI based app for storytellers. It's a more of a creative assistant for storytellers, where they want to build stories, and they wanted to have some control of the app, where they say, okay, they provide the character types, personalities, and genre, length of the story, so on and so forth. And the second one is like, it's a more of a customer assistant for some electronic appliances. Here we are talking about an oven as an example, where by uploading a picture of the equipment, we want the system or the solution to understand the image along with some problem description that user is going to provide, and provide as an outcome instructions on how to solve the problem and how to address it. So while the first use case is more of a text input, text output, the second one is it's a multimodal where you provide the user provides the image plus text and expects some instruction in the text format. So with that, let me move on. And so when you have a use case, you wanted to know how do I go about it, right? And you need to do some experimentation, especially with AI. Any AI application, the first step you do is some POC or prototype, or prove that you can solve the problem in a meaningful way, right? So now let us see what options we have in GCP to do the experimentation. So in this section, we look at two different aspects of it: what kind of LLM models we have that's in GCP that we could use, and also what kind of tools we have in GCP that enables us to do the experimentation, right? So this here we have a list of models, and then here I wanted to just bring out the point that okay, you have a plethora of models within GCP that you could use based on the your modality needs and what's your input and output needs. Whether you wanted to go with a foundation model or you wanted to go with an open source model, yeah, as you can see, you have Gemini models listed here, and also open source Gemma models from Google itself, and you have other open source models from like Claude or like Mistral and Hugging Face models as well. So if you see here, you have models identified based on their key differentiators. So for example, if you look at Gemini 1.5, 1.0 Pro, this is best one for multimodal reasoning across wide variety of tasks. But 1.5 is one step further, where along with multimodal reasoning, it enables you to give 1 million context window. This actually opens up the way or changes the way we solve the problem. Say, for example, earlier, if you have a long context window, I think before 1.5, most of the models are in the context window range of 32K. But if you have more context that you wanted to provide, say for example, I wanted to have say entire code base of a company, I wanted to do some coding analysis or find bugs or fix them. Earlier, you need to do something like RAG, where you split them into chunks and do the retrieval and get relevant context, which is an overhead. Now with 1.5 Pro, we may not need to do RAG, especially for applications where we are not really bothered about not real-time applications. We can definitely use 1.5 Pro. We are able to upload say 300-400 pages of PDF file at once and ask descriptive questions on it, and we see a great performance there. Similarly, 1.5 Flash, which is a bit of a purpose-built option for high-volume tasks and also for low latency tasks, right? That's where Flash comes into picture, and you have Gemma models available from the same technology of Gemini, but a little bit lightweight models, and that those are available in the open source, open source fashion. Similarly, we have the rest of the models. So I'll show some of these in the Vertex AI, GCP Vertex AI window. But before that, let me quickly explain how an API for these Gemini models look like. So this is an outline. This is not some of the actual code I'm going to show in a while, but there's an outline where you instantiate the model, and generate model is a standard one where you can provide the model name that you are looking at along with the version it has, and you have second section as the configuration, right? So how you want the model to behave, right? What is the temperature you want it to look, and what is the maximum output token, so that the outputted content is controlled, the length of the content is controlled, and there are a few more configuration options that we will discuss. And in addition, which is a very important one, is the safety settings. Google is known for developing AI based solutions in a responsible way. So Google is proactively providing some safety controls to the user, while some of the safety controls are like non-negotiable, where Google controls them, but there are some safety controls where the API gives flexibility to the user, so that the level of safety you are looking for is can be controlled, right? And then we have the prompt text here. This is a sample one, and then we this is the piece of the method to get the response. where model.generate content while and we pass the prompt in the text format, as this is a text model, and then the configuration parameters and the safety settings parameters, and also we can control whether you want the output to be streamed while it is generating, say, like line by line or like paragraphs, or you want entire output to be displayed on your screen or like received at once. So the stream true will give you output as it is generated, when stream false will give you output after complete generation of it, right? And towards the end you can actually print or print or process the responses. So this is for a text model where Gemini 1.4 text one. So now let's look at the second one. This is for a multimodal one. So here, as an example, I'm taking Gemini 1.0 Pro Vision. You could take other multimodal ones like 1.5 Pro or like 1.5 Flash, so on and so forth. Here, the outline is more or less the same. For the text one big difference here is the prompt list. Earlier, we had a single prompt, but here we need to send the images and text as the input here, because if you remember, like the multimodal is the ability to take multiple types of data as input. So here that's what we are mimicking here. You need to convert your image into part format if you're using the API, and then you need to send the text or prompt along with it, right? So in the generation config, system settings, so on and so forth remains the same. So now we have seen the different Gemini or like other models available. Now let's look at what are the tools available in GCP for you to do the experimentation. So there are multiple options based on UI based or API based, and some are for like production ready code development, so on and so forth. So one is the Vertex AI Studio console, which is available on the GCP GCP console itself. Second is the Vertex AI Workbench. That's where general most of end-to-end work happens along with the Cloud Shell editor. And the famous Collab is also available, where we can just call these APIs from the Collab as well. So as part of our today's session, I'll explain or show Vertex AI Studio console for our first use case for the code for story generation, and I'll use Collab for our multimodal image and assistant generation. Okay, and in addition to this, though it is not mentioned here, we have Google AI Studio, which is a console completely outside GCP, but still you could use your GCP project key to do the prompting there as well, right? So now let me shift share Vertex AI console. All right. Okay. So this is a Google Cloud Platform user interface. Here you have Vertex AI console. Here you have on the left side you have different links for it. So majorly you have the Vertex AI Studio, which is meant for all your regular AI or Gen AI experimentation. So if I go to the overview part of it, so this kind of gives you a list of different types of models based on the modality. There are like language models or like vision models or speech models, so on and so forth. And if I go to prompt gallery, here is an interesting part, right? You already have some sample prompts already built for you to explore. If you're kind of new to Gen AI, this is the best place to start, right? So you have some prompts already built, right? You can just select that and run it. I'll show you how to run with some custom prompts, but this is a good place to start with prompting. Then you have the next four links are related to if your use case is multimodal, then you go to multimodal section, where you go to Gemini 1.5 or Flash or Gemini Pro. And here there are models related to the language. Again, you have earlier text Bison or Gemini models are available, and this section gives you vision related ones, where if you want to generate image, That's when you come to this place, and either you can just generate an image using a prompt, or you can give an image and try to edit it by with a prompt, right? And the last one is the speech related one. Again, this is LLM Gen AI based version of the text to speech and speech to text, where you can simply give the text and a speech will be generated. Again, you can upload an audio file, and you can have the text translation generated here, or translated here. So now let's, for our use case, I'm just going back to our use case. We talked about two use cases, right? So one, we wanted to generate a story, Gen AI based app for storytellers. So we saw that, okay, this use case is more of a creative use case, right? And there is a creative use case, and let us see how we can put a prompt, and how we can make the prompt production ready, right? So for example, if I have some prompt here, like, see here, I mean, I have a prompt simply put up. Simply I asked, okay, create a story of a friendly cat. And I used a Gemini 1.5 Flash. Sorry, let me explain these options a little bit. On this console, when you go to a language model, and on this console, you have options to select what Gemini model you wanted to take. As this is in language, all the models that support text output, you can see. So here, if you see, you have the little previous version model as Palm 2, and the latest Gemini era models as, like, Gemini Pro 1001, 2, Gemini 1.5 Pro, and Flash, everything. So next, you need to select the region, in which region you wanted this prediction to run. And third, you need to select the temperature. Temperature is an important config parameter for any LLM, right? So temperature is like, you can think of that helps us change the response behavior from more deterministic to more probabilistic. Meaning, if you want the response to be a little bit more creative, you have a higher temperature. If you want your response to be very strict, where you don't want too much of creativity, you don't want much of hallucination, then you have a lesser temperature. Okay, so for this, and you have the output token limit here, how many output tokens you can achieve. So we have that 8,000 plus output tokens, and it can take 1 million, which is 10 lakh input tokens, right? And you can also have a stop sequence here. Say, for example, in creative tasks, if you want to have a stop the response, if you see a specific word, that's where you can use it. There are safety settings which are very important here. So these settings is based on the likelihood of the response that could generate either harmful or inappropriate content, right? So you have some lever here for each of these safety area, right? Hate speech or dangerous content, explicit content, and harassment content. You can actually select how how strict you want to be with that specific filter. If you want to kind of block only few, then it would block only few. If you want to block most, you don't, say for example, you don't want to have any hate speech in your response, you can block the most. But if you are okay, if you are doing some research kind of use case for your internal users, you really wanted to analyze something, then you're okay to have a bit of hate speech in your response, then you can block a few. Okay, but again, this is very specific to the use case to use case. By default, we have it block some or block most. Okay, and there are few advanced ones, maximum number of responses, different variations of it, and top K, top P. These are like, how the next word in the generation would be taken, and so on and so forth. You have options to enable grounding by default with Google's grounding service, and few other parameters. So with that, let me just show you the response of this chat, right? So this text, I simply asked, create a story of a friendly cat, right? Then you can see the response. It has generated some it has generated some story, it has assumed some name and gave a flow of it. But the problem with this kind of response is it is not really structured, right? You do not have control of, what's my cat name, what should be my character, how lengthy the story should be, what is the genre of the story, and those kind of things we have not provided. But when you want to build an app like this for storytellers, obviously they want to have that kind of controls. Now let me show you an improved prompt of this, right, where we have a few things mentioned here. Here I mentioned, okay, gave a role saying that, okay, you're a creative storyteller, and also asked, okay, write a short story based on the following premise. If you see here, I kind of gave few parameters similar to if you write a function where you wanted user input to be captured. Uh, I wrote the prompt similar way, where we take character name, character type, and character persona, like, what is the location in terms of where the story is occurring, and what kind of genre the story is, like an adventure, like, romantic, friendly, so on and so forth. And and you have another section called instructions here. So the instruction actually gives guidance to the LLM in generating the response. Here we are saying, and here whether the story is short or long is also we can take from the user. Okay. um, Here I have given few instructions, like, if the story is of short, then make it 5 chapters, otherwise 10 chapters. That means we are somehow controlling the output, right? And uh, so, and again, each chapter we are saying, instead of kind of hallucinating, generating different chapter with different premise, so make sure you're sticking to the core storyline there, like, and also we are giving some instructions, like, give some introduction to each of the chapters, starting and ending, so on and so forth. So if I put the prompt in this way, you see the response here, like, there is a nice heading there, and also there is a prologue, like, like, some background about it, and each chapter, like, chapter 1, new world, and the space explorers. This is really nice, right? And so just the word, by giving the word, a galaxy, it is able to put the story in that, outer earth kind of atmosphere. And the names are also like that, exploring a different, cosmic crisis, and also having a specific epilogue, right? So as a storyteller, they may like this kind of thing, right? So just by changing the prompt and giving a structure to it, and separating it from user input parameters, and giving instructions, giving a story, we are able to get to a really nice story. So now, in due course of this session, we will see how this prompt will be used in the end-to-end application, and we'll also have a UI to show. And the same demo you would be able to use even after this session as well. So I've taken the extract from that demo itself, so you can play around. So you see, Charu is going to show you, like, how the prompt looks in UI, and you can kind of give different values to these parameters and play around with it. Okay. So with that, let me so that was the first use case, where we wanted to create a app for storytellers, and we have a prompt in place. In the next sections, we will show what are the few best practices and how do you put this in end to end. But before I go there, let me show you one more thing. So for example, you did this experimentation. Now you wanted simply to put it into API code format. If you see here, you see that get code option here. If you just click on that, you already have a code already instantiated with your project, and with the Gemini model you are planning to use, with the configuration parameters that you have used, and also prompt put up here. You see, so that means you can just simply open the notebook and play around a little bit with. That's the first step in trying to productionize this solution, right? From a prompt to making it an end-to-end application is, from a GenAI point of view, the GCP already gives you the first step already created. Okay, so This is one option if you want to convert very quickly into a code part. Let me now go to the second use case, which is where we wanted to um, second use case where we want to create an appliance usage helper assistant, and we want to provide the equipment image as well as the issue text as input, and we want to get instructions as output. Now let me use a collab notebook to demonstrate this one. So here is a collab I have created. Okay, and this collab is taken from the Google Cloud Generative AI public GitHub. You'll be able to get it pretty easily. So let me very quickly go through the steps here. So I'm installing the GCP Vertex AI platform here, and then I'm doing the restarting the runtime, and as I'm accessing from Collab, this needs some kind of authentication. While I have authenticated this with my name earlier, but when you run it for first time, you need to authenticate with your account. Next, we are importing the Vertex AI generative models, different methods there. And then we need to actually provide what is the project ID and location, or the region location. Here I have provided mine, but for you, you need to create that project and location, and need to give those details here. Next method is like I'm just loading the models. If you can recall, I've shown you earlier, right? So generative model, and I'm providing the flash preview as a model I want to use, and I'm returning that particular model. Next is I'm just calling the model there, along with I'm initializing the temperature and max output tokens and other configuration parameters here. And here, model.generate content that I've shown you in the slide actually takes the prompt list that includes both image, part object of the image, and also the prompt text, and also the config, again, stream true or false as well. So once you get the responses, this particular method is actually just processing the responses and returning that into as a final response. Now we have the model classes, like functions defined to load and call the model. Let me show you what data we are using here. So the image. So I have an image in my GitHub GCS bucket, and I'm actually loading it from that and displaying it here. Okay. And this is the prompt I'm using. So this is a simple prompt. As earlier, this can be still further played around with and expanded. And you can even, if you have an image, you can log into Vertex AI Studio and go to multimodal section, just upload the image in the UI and play around with it, right? So here I'm giving this particular instruction, like this is the query I have. How can I reset clock on this appliance, right? So here we are not giving any more information. We are just giving image of the oven, and we are just asking the question, right? So we are instructing it to provide instructions in English, and if the instructions include buttons, like in this case, and now we are also asking it to explain where the buttons are physically located. We are setting the temperature to 0.1. If you recall, the earlier temperature we set up for the storytelling use case is little high. If you see, temperature was 1 here, but here in this case we are setting the temperature as very less, 0.1. The reason being, for storytelling we wanted model to be little creative in its output, but here we want the model to be more realistic rather than creative here. So that's where you see the usage of temperature, how we are using, right? So we are using a less temperature here with the max output tokens of 2048. Here, one additional step we need to do for the input image, we need to convert them into part part object here for the source image that we are using. And then once we have that prompt and part object of the image, we just pass them to the model. This is the model we earlier loaded, and then here we are using the prompt list, right? One is the image part image, and also the prompt and the configuration. So this is the output we got, where So where we are saying like it is first asking to click on the clear or off button to clear the timer, and then click on the clock button, and also use number buttons to enter the current time, and then lastly, and it's asking to start button to confirm the time, right? So see, if you see, all the input it has is only the image, and it's able to clearly give the instructions. So if you want to enhance the solution further, right, so have you may have the user manuals of this particular appliance, and you could use those user manuals also to ground or confirm the solution, right? You can take this image, user manuals, maybe you can use this image to identify what kind of appliance it is, and maybe go to the user manual, the relevant section, and get much better results and much wider application of this solution. So this can be a full-fledged customer service app with that approach. And again, we will show you how once it is kind of put it into end-to-end format, how it would look like, and Charu will give a demo of that as well. So with these two prompts in place, let's go back to our deck here. Just to just to summarize, we have looked at Vertex AI Studio console to look at how we can give a prompt in UI and also refine the prompt. And once the prompt is ready, we can just by click of a button, we can generate a Collab notebook or an API code for it. Second, we use the Collab for the second use case, while we use API approach to upload the image and text, prompt text, and get the response. Now with that, let me show you quickly what happens when you hit that submit button on the UI echo. What happens in the background when you do an API call to the Gemini or like other LLMs that GCP hosts, right? So you give the prompt, right? And then it goes into a layer of responsible AI and safety filters module, where it would look for any issues with inappropriate content, or like whether it is following Google's AI principles or not, so on and so forth, and it would reject if it is not following that kind of filters. Second, once that filter verification is done, it goes to the foundation model. It actually the foundation model could be like the base model or a fine-tuned model, so on and so forth. There may be a custom setup you may put up to tune the model, evaluate, deploy, and monitor the tuned part of it using Vertex AI there. And if you have a tuned version, that can be used as well. But if you are directly using the foundation model, the call can be done to the foundation model. And there is an additional or like an optional step where the Vertex AI supports like grounding service, where you can give some factual information, where you wanted to check the response again is that factual information, so that hallucination can be reduced, right? So on that service, if it is there, that response will go to that service, and then it goes to the citation check. Citation check is when if a response is resembling too much to the data set that's been trained the LLM, right? And Google, as part of its commitment for a responsible way of developing AI applications, it actually gives a citation of the source, so that the source gets the right recognition there, and that citation will be added. And again, it comes back to our responsible and safety module. And once the all these steps are done, then the output will be again checked for correctness, or like correctness from a responsible and safety AI point of view. And where we have I have shown you in the UI different filters, right? Like hatred, or like inappropriate content, so on and so forth. If the output is generated, the generated output is not following Google's responsible filters, then it would be blocked. That's why when you put a query to Google LLM, sometimes you won't get the response. That is because either the input filter or the output filter had blocked it. Okay, that is the thing you need to be aware of, and then you will get the response. So this is the end-to-end flow that you see in Vertex AI when I call an LLM. So it is, so if you kind of understand, This Google is doing its best to make sure proper content filtering is done both at input and output layer while you're calling the foundation model. But this may not be use case specific. So in addition to, we'll discuss a bit more in our design consideration section, where you need to pay much more attention specific to your use case on how you build a good Gen AI based solution. So with that, let's look at design considerations. So any AI application needs some good design practices, and with Gen AI, I think the given nature of its great capability, we need to be a little bit more careful when we design an application, especially for end users or any other users. So these are few design considerations. The first one, I personally would like to treat Gen AI tech similar to human intelligence, because we moved on, like now earlier we used to have more instruction based systems before AI. With AI we got a little bit more of learning, but with Gen AI I think they are a bit more closer to human intelligence in terms of the intelligence, right? Not from the experience, memory, judgment, so on and so forth, but from intelligence point of view they are similar. They are like behaving similar to Gen AI, similar to human intelligence. So for that reason we can expect few behavioral things that we see in humans, right? So for example, hallucination is what, like it's being creative, right? Sometimes telling something very convincingly though it is not correct or factually incorrect, right? So this happens with humans as well, intentionally, unintentionally. When someone is not up to date with the factual information, they say something but that may not be right always. So this feature is useful when you are looking for a use case, something like a creative use case. That means you need to think creatively. That means that's where, like this hallucination becomes a feature of an LLM here. So that's where we see in the we see in our storytelling use case that that creative thinking helped think creatively and beyond, like in the galaxy systems, and how Mitten would do adventures there, right? So but this hallucination can become a bug for a deterministic use cases. Example, our second use case, right? So if the LLM response imagines something that's not there in the one image, that won't work out, right? So we need to be very careful in handling these hallucinations, and there are a couple of options to handle this, though it is still a research area. One is the temperature is one good option to handle hallucinations. If you have a deterministic use case like our second one, you do the you use less temperature. If you want your response to be creative, then you use higher temperature. And also, like you can use external content, like giving more context to reduce hallucinations. So for example, in the first use case we gave very strict guidelines of the genre of the story is this one, and we want the length of the story is this much, and also we want the topic, or like premise of the story is this much. So by giving a proper context and instructions, we can reduce and handle hallucination, or like we can get the right response we are looking at. Next, inconsistencies, right? So inconsistencies again, like what this means is, if you run the for the same prompt, if you run the if you do LLM calls multiple times, you may see slightly different responses. So when you say, okay, I want to get the same wording pattern and same sentence every time, you may not be able to get it. So because it's something like humans as well. So if you need to remember, say 10 sentences paragraph, and you by hearted it, and if you are telling first time, you may be able to tell in a different slightly one way. And if someone asks you to repeat the same thing again, you cannot repeat the exact same thing, the same order of the same words. So it is a behavior, you can loosely relate to that kind of behavior. So inconsistencies, how we handle here is like, if your application needs every time the response is in a specific format, you better give that output format in the prompt itself. So for example, you want your output to be in JSON format, so the format is always right. So you can use that for a downstream applications. But if your use case is creative, like our storytelling, it's okay for us. Actually, we really need that kind of inconsistency, that creative nature of it, right? So that again becomes a feature there. And third is the training data bias, right? So you may have some training data biases, where the LLMs have been trained on. It may not represent all kinds of places or kinds of people, culture, so on and so forth. To address that, it's actually more of an LLM controlled one. But from a prompting point of view, we can instruct the prompt to say, okay, make sure you think like a global citizen, make sure you consider all cultures, make sure you consider all kinds of people, so on and so forth. So we have seen responses becoming much better by including these kind of holistic thinking instructions in the prompt. So these are just few of the behaviors that we expect from LLMs, but there would be many, right? And next is we need to build proper guardrails, right? So we need to make sure the app we are building sticks to its purpose, right? So for example, you have I'll give you an example, right? So here I have let me share the screen. Okay, so this is an internal demo that we built for fun. Okay, and here this app is intended for students to learn Python, like answer questions related to Python, answer generate code in Python, so on and so forth, right? So this, if we open up this app for everything, then it wouldn't serve the purpose. Second, this app becomes like LLM testing for the students. So what we have done is we have instructed it to stick to its purpose, and by doing so, we are able to kind of control behavior of the app, right? So for example, if I ask something beyond or not related to the programming, then say for example, who won the IPL 2024, you can see it very nicely saying that, okay, I can answer only programming related questions. Again, and that's a generic guardrailing part. There is a use case specific guardrailing part is there. Say for example, the customer wants to have this app used only for Python students, not for other students. So we again handle that. And if you see, if I ask it to write some program in a Java, and it simply says, okay, I'm configured to do only in Python programming. Again, this is another way of doing guardrailing specific to the use case. Okay, and here we are actually identifying it is asking a Java a question, and we are actually mapping with the pre-configured content of what is an allowed programming language or not, and then we are putting our response. So if I ask, okay, oh, all right, write it in Python. If you see, I did not mention again, like what task to do. So that means it's able to actually remember the earlier context and writing the code in Python. So this is one way of handling guardrails and sticking your app to its purpose. Okay, so and this also helps us do the prompt injections, like now the input is English or like a plain natural language, so it's quite possible to change behavior of the apps. We need to be very careful with those apps as well, right? So, and the third and most important one here, like we need to choose the right LLM model. So when you choose the right LLM model, you need to be very clear of what input output format you're looking at, how is the performance, what is the context window, sorry for the typo here, context window, and tuning capability, production readiness, so on and so forth. So context window makes a big difference here, right? So for example, before 1.5, Gemini 1.5 model, earlier models were less context, right? Like Gemini 1.5 is 1 million context tokens it can accept. So if you see, earlier there are use cases where we used to follow the RAG approach just for your purpose, like when the context is more than the context of, say for example, that more than 32k, what LLM actually supports. We need to actually chunk all the content and put it into different chunks and retrieve relevant chunks at the query time and send only those specific chunks to the LLM call. But now with 1.5, you can actually take entire context up to 1 million tokens. We are talking about like almost 40 the 10 million tokens, approximately 40 million characters. You no need to do rag at all. But this may the you can send entire context in one go, but this may increase the latency, right? So you need to carefully judge for my use case which model is better to use, right? So that's very important to consider. There are a few more considerations, like you better standardize the prompt, and we'll kind of look at a sample prompt in the next slide. And also make sure you do the proper pre and post processing for LLM input output. This pre post processing is mainly to make sure your user query or like input from the previous system is in the format LLM needs, and you handle edge cases, so on and so forth. And another important thing is like you define data refresh strategy, like how frequently, if your application is data dependent, as the first step, you make sure you have a proper data refresh strategy. And also take care of sensitive data filtering. Sometimes, say for example, you have a human resources application, you wanted to build a chat app for like HR, on the HR team, then you need to be really careful about you don't put PIR, like personally identified data into the system, right? So that means you need to do that processing first itself. And also design for data security at both data sources level and also the app level. Like if there is a sensitive data in your app, say you wanted to build a enterprise level information retrieval app, then you need to be careful, like when do you want to put all the entire data of the enterprise, like financial data, HR data, some sensitive confidential data, all those things. You need to be careful what data sources I want to put it in my app, and also how, if at all you wanted to put it, but how do you control at app level in terms of security and authorization and role based access, so on and so forth. And again, ground LLM responses with additional data sources to make sure the hallucinations and such features are kind of reduced. RAG and providing proper context would help do that. And importantly, consider positioning GenAI application as an assistive system, right? So this is an important consideration to look. So there may be, given its capabilities, it may look like, wow, I can do everything with GenAI, and I can trust the application 100%. Just put it as an assistive system, and but not as a decision making system. So there should be some human intervention in taking that response and providing a due diligence before acting upon it, right? And last one, when you experiment and evaluate, it is not just the LLM you need to consider. You need to actually consider combination of LLM plus LLM configuration plus prompt for the input data and output of and expected outcome. So if the combination of LLM plus config plus prompt works, that is the crux of your solution, right? In addition to the regular code part of it, right? So you need to make sure for that combination you are getting the right output for the given input. So here this is a sample prompt. Well, I don't want to go through it completely, but I just want to highlight few things here. So instead of keeping prompt just open-ended, you make sure you give some kind of persona to it or goal vision statement. This prompt is aimed at a travel assistant. So if you want to know an assistant built for travelers, right? So here we are saying, okay, what is the persona and goal? We are really talking about act as a seasoned travel blogger. Okay, and also make sure you kind of bring up hidden gems and creating unforgettable travel experiences, right? And also here, if you see, we are mentioning do not respond to queries not related to travel planning. So this is similar to the learning assistant earlier mentioned. These kind of statements will actually make sure your app is used only for or responded only for the travel planning related ones. Then we are also having a context. What is the context of this app, right? So we are saying we have a lot of customers between the age group of 20 to 35. They wanted like adventurous, budget conscious trips, and then they are looking for recommendations that are interesting and memorable, not a regular routine ones. And we are actually giving very specific instructions for the output. Your task is to focus on inspiration, detailed planning, and logistics, so on and so forth. And also outline or document potential user journeys and those things for a specific location, right? So and here we are again giving the tone to go beyond the regular itineraries and make sure you have innovative ways to suggest. And the format of the output, you see here, this inconsistencies can be reduced by giving a format of the output. And this here, the format is given in an instruction format, but for a technical use cases, you can even give a format in a JSON format or so on and so forth to get the output. Here we are really asking to generate a table with columns, day, location, experience, so on and so forth. And then we are giving input and expecting a response. So by giving this kind of prompt structure, or a structure to your prompt, it helps in two ways. One, it gives you the required input, and second, it gives you an option to capture any responses you are looking or like inputs looking from the user. Third, it makes making your solution upgrade from one LLM to the other if at all you need to be done. Okay, so these are a few things. Another quick thing with Gemini, we observed that providing a positive sounding statement makes a bit more sense than providing a negative sounding statement. So instead of saying do not ask for interest or do not ask for personal information, you can say it should refrain from asking for users of their preferences and avoid asking for personal information. Okay, so these are few tips. And finally, before we go to the next section, uh, so you make sure once your experimentation is done, you say that okay, I have a solution path to build this solution. But before you put up your design and deploy phase or a proper build phase, you make sure all these things are finalized. One is the what model to be used, obviously what model to be used, and what configurations to be used, like temperature, token limits, safety settings, so forth. And what is my prompt, and what are the static and dynamic parts of the prompt. Like dynamic part would be the one where you take inputs from the user or other systems. And prompt flow, and we have seen when we have a multi-stage system, a prompt flow is also important. Say for example, you may want to first classify user question, right? And then you based on that, you have your solution path, and you may want to ask additional information from the user, and then that asking additional information is another prompt. And again, maybe third, once you get all the information and acting upon or retrieving some information would be another prompt. So it is not just one prompt. There may be a scenario, there are multiple prompts in a solution. Then you make sure you do the testing, and you make sure all the prompt flow is also working well. As we discussed, guardrails for the solution are important to consider. And also make sure you have an evaluation strategy. How do you evaluate your solution? How do you capture the feedback, right? How do you act upon the feedback, so on and so forth. Lastly, and most important one, what are the costing estimates? How many calls am I getting maybe for a day for a number of users, like, and how many characters are there going into the each call, and what is my cost, and what would it cost, so on and so forth. So these are some design considerations and few things that needs to be taken care. And now next let's look at the design and build of the end-to-end solution. And with that, I'll hand over to Charu.
Thanks, Naveen.
Charu.
Thanks, Naveen. Right. So now that we have learned about how to call Gemini models, how to use them for different use cases, be it text generation or be it using multimodal images or PDFs or video inputs and get the or generate the content out of with the use of them. Um, as well as we learned on how to use different services of GCP to experiment. For example, using the Vertex AI Studio or using the Colab Jupyter notebooks. Now that everything experimentation is done, we'll now need to look at the bigger picture of how we can use the experimented code and then build it and use it for the production as in writing. So here we will talk about writing the code and move it to the production. So this is just a component. Each of the components in the slide that you now see will help you move the application from experimentation to the production level. Starting from the first component, which is the IDE. Here, you have flexibility to select any of the IDE and your choice of programming language to build the GenAI solution. Um, I'll be showing you an application which is built on Google Cloud IDE code editor. Once the code is experimented and you are sure, you can move it to the cloud source repository for the version control. Once the code is finalized and moved to the cloud source repository, we have to build the source code. We can use the cloud build, which is provided by the GCP. There are two options after this. You can either move this build code, which is moved into, which is in the container images, and we can save it to the artifact registry, or you can directly go ahead and deploy this code with the cloud deploy. Um, Once this is done, you want to use the runtime environments. There are multiple options we can use. One of the option is Cloud Run, which we will look at the application that I'll just demonstrate. If it is there is another runtime that you can use is which is most often used is called Cloud Functions. So the difference between Cloud Run and Cloud Function depends on how you would want to deploy your application or how you would want to serve the purpose. If you are going to serve it the entire solution as an application from end to end, then you can go ahead and use the Cloud Run, which is most often used. But if it is related to just a smaller section or just serving of some a part of the functionality of your entire system, then you can use the Cloud Functions. Internally, it supports containerization of the code that you would write or the function that you would write in the Cloud Functions. At the end, there is also a support, or you can use the cloud logging and monitoring to know what is happening when your application is running. What is the stage it is currently at, etc. And this was just a bigger picture on how the entire application, you can move the entire application from the initial stage of writing the code to the productionization. This is just a smaller version or simpler version of what we are going to see now. Is we will be showing you Streamlit application right here. So currently we will not write the code right from the scratch, but I'll show you the already written code, and you can go ahead and run the code at your available time. Once the code is prepared and you are ready for the deployment, you have Google Cloud commands, which you can use to deploy this code on the Cloud Run. As I mentioned, this is gonna be a web application. That's why we are going ahead with the Cloud Run service. Otherwise, if it was just a smaller functionality, we could have used the Cloud Function. This code is internally going to use many Google services. And one of it is now, as we are speaking, is Google's Gemini model, which is multimodal. And once the deployment is done, any user who has access to the URL that is going to be generated can access the application and use it. So as I mentioned, the application that we are going to show is built on Streamlit platform, but you are free to use maybe a Flask framework or Gradio applications. There is no constraint on it. Or maybe if your application is very complex, that very depends. But for simplicity, I have used the Streamlit framework. And in the application that I'm going to be showing you, as I mentioned, we are not going to write the code from the scratch. That's why we start with cloning the code that is available on the GitHub repository. And then from here, you will start on moving it to the build it and then moving it to the cloud artifact registry and then deploy it directly to the cloud run. And once that is successfully done, you get the URL and you are good to go and access the web application. So I'll go ahead and show you the application first, and then understand how it looks, what is the functionality, and then we can move ahead and look at the code. So that's easier. With that way, it will be easier for you to understand. All right. So this is the web application that Naveen mentioned and showed you how you can write a prompt and maybe experiment either with Gemini's text model or with Gemini's multimodal Gemini Pro Vision model. So this is the application where you can see 4 tabs. Each of it serves a different use case. So this particular use case serves for generating a story, and this was covered by Naveen. It generates a story based on the parameters that we provide as well as the settings that we choose. So these settings are directly used to set the temperature, and the initial settings that we provide are used to generate the content or the context that will be used for the text generation or the story generation. In the below, once you click on the generate my story button, you get the result generated by Gemini text model. And there is a smaller next tab beside it, which is called prompt. It will show you what was the actual prompt that was created while generating this story. And this goes for all of the use cases that you see in these tabs. Under Gemini Playground, you have a use case on or a demo on furniture recommendation, glass recommendation, even the oven instruction that Naveen showed you, where it takes multimodal inputs. Multimodal means it could be image, video, a PDF file. Here it goes similar way. It takes this question or instruction and it generates the steps to solve or to answer the question. The last tab is for the video data for the Gemini model, and it has 4 different use cases inside it. So this goes for the application. I'll just quickly jump back. And then this is the screen on which you can access the application that I was just showing. It is available here, or you can scan the QR code. And this is the GitHub repository to which even I'll be showing you the code of. You can use the QR code or go to this link and you will be able to access or clone this repository. All right. So for the deployment of this application, we will have to clone the repository that I just showed you from the GitHub page, GitHub repository. Once that is done, you will have to run few commands that I'll be showing in a while. And then we should be good to run the application. Let me just switch the screen. All right. So once you replicate or clone the repository on your IDE or any environment that you are writing the code on, the repository or the folder in which you need to go to is Gemini Streamlit Cloud Run. Inside this, the starting point for you to be would be the README file. Let me just open it in preview so that we can follow the steps simultaneously, and I'll explain you what each step would mean. All right. Once the repository is cloned and in the terminal, we are in the exact repository. Okay. I'll just... So there are two options. First, since we are directly using the code, we would always want to look at how this would look like at the local web page or local host. And then once we finalize, we would want to deploy it to the Cloud Run. So let's follow this commands, and this will help you look at the web application on your local environment. So I am now creating the virtual environment and install all the packages that are listed inside the requirement.txt file. So I'll just quickly go ahead. Once this is getting installed, I'll show you what are the libraries that are going to be installed. First is Streamlit, because this application is built using Streamlit framework, and then the two cloud GCP cloud libraries. One is AI platform, and the second one is for the logging. Okay. The other file is a Docker file, which we will use once we move the containerized application to the Cloud Run. And this file will be used to set up the container image. This will expose the port to 8080, and it will install all the packages in the container image as we are currently doing on the local environment. And then it will initialize the application using the command to start the Streamlit application. All right, looks like the environment is set. Now we need to set up environment variables. Okay, let me just clear this out. Okay. So the project that I am currently using is accessible here for the project ID. I'll just copy the ID, and then I'll continue with the US region. Okay. And we are good to start the application on the local. All right. So now you would get the link here which says localhost. But if you try and run this link on your browser, it will not work. The reason is we are using the cloud shell, and you can't access the links outside of it. But Cloud IDE provides you this web preview button here at the top. You just need to click on this one, and it will show you what is the port that you would want to use. But now with the command, we are using same port as 8080. We are good to go and click on this first option. But if you would want to change the port, there is an option to do that as well. So I'll go ahead and use the preview button, and it's running on 8080 port. Give it a second, and then it will load the application. So now that the application is running on localhost, it's not yet deployed. It's just experimentation, and we are just making sure everything works well. All right. So I'll just close the application and come out of the command on the terminal. So once you are good and you would want to deploy the application on the Cloud Run, um, this is the section that you would want to use from the README file. The project and regions are already set, so I will not run these commands again. We'll go ahead and let me just go back to the slides that we saw earlier, and just go back here. So now we have code, working code with us. We just need to build the code, move it to the cloud artifact registry, and push it to the Cloud Run. And once the deployment is done, we should be able to access the application. Okay. So first was to create the repo. So that's why let's create a repo called, let's say, I'll just create a repo with some name, 28. And the service name here means the Cloud Run service that will be created will be called as Gemini Streamlit application. There are some commands to which we would want to give the access to. So first command, we'll create a repository with the name my AR repo May 28. Oh, sorry, I missed the entire command. So this command says we want to create artifact registry with the name as this, as we gave it in the environment variable at this particular location, which was already set, and the format of the repository that we would want to use. So this is a Docker format that we want to use. Docker helps you write code in any of the programming languages, supported programming languages, and then deploy it without the constraint. All right. The command that I just pasted gives the gives the authorization for the Docker configurations to the artifact registry that we just created. The next command will take some time. The environment that I had created would have installed all the libraries. So I'll just go and deactivate this particular environment so that it okay, so it is now deactivated, and we'll go ahead and run the cloud build command. So this command will just start the container image building process, and then we will move the containerized image to the cloud artifact registry. Okay, let me just delete this one so that it does not move everything from the virtual environment that we created, and it takes less time. So rerunning the command. Okay, so now this is going on and will take some time. I'll just go ahead and explain you the code in short. Okay, so app.py is the main file which has written the Streamlit application. Initially, all the import libraries, then environment or the variable setup, and Vertex CI initialization. Two main functions are here. One is on the Gemini Pro text response, the one for the use case we saw. For the first use case on generating the story, we'll call this particular helper function. It sets the safety settings as Naveen showed you, gets the response with the prompt that we provide and the settings. And the second helper function is on the Gemini Pro, which takes the list of prompts. It will be a combination or image or video, and it will generate the response. So here, as we saw, there are 4 tabs, and for each tab it will set the parameters and then generate the story on what were the parameters set. The configuration or the temperature settings are done with the controls that we saw on the UI, and the major important part is the prompt. So this is the basic prompt or the initial prompt that we set. It gets the configurations that we select on the web page or web application, and then it generates the return response once the button is clicked using the helper function. So each of the use case has their settings that we select on the web application, the prompt, and then it calls the relevant helper function. Goes on for all of the tabs that we saw on the UI. So this one is for the use case on recommendation use case on selecting the glasses for a user. It takes the parameter that user selects, and then generates the response using the prompt that is set once the button is clicked. All right, it seems the command has finished. Let's move to the next command, which is the last command to deploy the application on the Cloud Run. And once this command is executed, we will get a URL which is clickable. So while this is running, I'll quickly show you how you can see the artifact registry and the container image that you have pushed to the artifact registry. Minimizing this. Okay, so this was the artifact registry name that we gave. And it should have the container image, this one, that we push to. It is a virtual, it supports version control. So if you make changes in the code and deploy it again and again, it will retain the versions here, and it will show you what is the latest version, so that you can use the version based on the numbers. Okay. So now it's still going on. Let me just open up the Cloud Run. Cloud Run. Oops. As you see, the application is still in progress of deployment on the Cloud Run. You can see here under the revisions on what is the deployment stage that we are going on. Currently, it was the first deployment. If we were to deploy, make the changes and deploy it in different again and again, you would see different versions getting deployed here. Okay, looks like it has completed the deployment. So here at the end, you will get the URL on the terminal, as well as within the Cloud Run, you will get the URL of the Streamlit application, and you can click on the URL and see that the application is now successfully deployed. Okay, so switching back to the slides, we have seen the code, run it on the local machine, local environment, and then first we have to build it, move the containerized image to the artifact registry, and then run it on the Cloud Run, and deploy it and run it on the Cloud Run. All right. Okay, now moving on to the Q&A session.
Yes, thank you, Charu. But before going to Q&A, I'll let you have a glass of water, take a stretch, and we'll be back just in a minute. Right? Great. Thank you very much for your questions. I always love it when it's so lively over there on the chat or on the Q&A panel. We have like a 2 pages full of questions, and our experts behind the scenes are trying to address them all. So I really like that you're using the opportunity to make sure you get everything right, make sure that you understand Gemini and you understand, even the basic concepts of Gen AI. Before we go to the Q&A, just a reminder, because I saw that on the chat, like someone was asking, can we do this for for free or something like along these lines? Yes, can I try it for free? And exactly, this is the moment where I would like to promote our Google for Startups Cloud program. As a cloud provider, we do have an offer for startups so that startups can build on us, their Gen AI solutions. The credits that we offer here can be used on cloud computing, on storage, on Gen AI, a lot of things that are available in Google Cloud. So under this link, under this QR code, share it with your fellow founders as well. We have an offer for bootstrap startups and VC funded startups. They differ a little bit when it comes to the amount of credits, but you can of course upgrade to a higher scale once you get the funding. But we're talking here about $2,000, $100,000, or even $250,000 for AI first startups. So a lot of deployment can be done on us. Okay, with that, because we're almost on time, I would love to invite Naveen and Charu back to my room. I've changed the room. Some people might notice, but that happens in a busy office. Let's go right into it. I will first ask about the cost. I was talking about the credits, so let's talk about the cost, because there are a couple of questions from different people, basically about our costs. So could you please discuss a little bit more in detail about the cost side of these customer service apps, and like how can we estimate the overall cost, also cost per ticket, cost per one query? So like we're gonna build something here, and like what can we expect and how can we estimate that?
Sure. I mean, I think it's a great question and it's a burning one, I believe, right? So there are a couple of different components that actually contribute to the cost. One is the LLM part of it, and that has subcomponents I'll discuss a little bit. And there is a hosting and services cost. In your end-to-end application, you have some services that are like compute engine or like some SaaS services or hosting services. Those based on standard cost. They are generally not dependent on number of tickets, queries, so on and so forth, right? That is one part of the cost. Second part of the cost comes from the LLM calls itself. So what is going into the LLM? It's what's going like it go every call. You have your prompt and you have your input data. So generally, if your prompt itself doesn't take anything from the user, then it's relatively easy. You know how many characters you get in the prompt, and you know an average output you need to calculate for the prompt. But if you have a user input, say for example, we were talking about the second use case where we are letting user to upload an image,
Or
right?
video, right? Even
Or
video.
video. Right. So there you kind of need to be little careful, like what kind of duration of the video or like quality of the image you would accept, because the size and that image or like video content directly impacts the LLM cost. So you need to actually in the from the LLM input point of view, what is the standard prompt that you are generating, that you are giving, like instructions, or like role play, context, so on and so forth, and what is the dynamic part. Standard part, it's very easy, but the dynamic part, you may need to do some analysis on what's your average user input, so on and so forth, and get to a conclusion. And in addition to that, I just want to share
Hmm.
a costing pricing sheet here. Am I sharing? Okay.
Not yet.
Okay, let me. Okay. Okay. So for once you know what are the input characters and what is your dynamic part of user input, you can come to this page and see what it would cost for you, right? And this public information can give you a tool input to estimate the cost. So I think hope that answered your question. In summary, you have two parts: what is going into the LLM, what are the standard hosting or services related ones.
Okay, gotcha. Thank you very much. A quick one, next one, because we were setting the regions today a couple of times in different examples, and the practical questions like how to make a decision about a region, what is impacted by this choice? Is it a price, speed, functional limitations? Rebecca Balabaco asked that, and yes, you are using US Central, if I remember correctly, while you are located in India right now. So why this choice, and how do we make this decision? And what are the implications?
Right, another great question. So I think one of the major decision points is the data residency, right? If you talk about US customers or Europe customers, there are very strong data residency requirements, and that's one decision factor. Second is like your latency requirements, availability requirements. Say for example, sometimes as these models are coming up new, and some models may not be available across the globe yet,
Mm-hmm.
so that also limits your region choice. And latency obviously also has some impact. There is slight difference in cost, but it's very minimal in terms of the region, but there is impact of cost as well. So these three, four factors we need to consider before choosing a region.
Okay, thank you. Um, I think last one, because we're over the time, but I think this is an interesting one because it was asked by a couple of people, and like when we're building something and deploying something for customer service, it's our customers, and we have to defend our brand and our good name, and we should not let any disturbance in. So what are the available guardrail approaches and tools in Vertex platform? That was one of the questions, but basically, are there any code examples for guardrails? And like, could you discuss guardrails a little bit more in detail?
Okay, so as I have shown in one of the slide, Google already takes care of some basic guardrails like harmful content and hatred, so on and so forth. And there are some configuration options for you. If you are looking at use case specific guardrails, that's where we need to kind of use the prompt I have shown you in one of the slide, explicitly asking like don't answer any questions related to beyond what's the purpose of this app, right? So those are few things we need to look at. I need to check about any code examples there, but that's what I could tell right now.
Okay, if we find any examples, we will definitely put it in our labs.
Sure.
And of course, there was also a question, but I got that from you, Charu. Charu, you were using in your example, what ID you were using?
So I was using Cloud Shell IDE, which is
Okay.
inbuilt in the Cloud Shell. We can directly click on the IDE button once you open the Cloud Shell.
Okay, that was a good stream. Guys, thank you very much. Naveen, Charu, thank you so much for this. It was lovely to have you here. And now let me finish up with inviting all of you, our participants, to our next startup school. Same time, same drill on Thursday, 30th of May. We're going to define user journeys for our Gen AI customer service apps. We're going to have Haran and Manwana with us. So without further ado, see you on Thursday. Thank you very much for spending time with us with Startup School Gen AI. See ya.